Well, I might need to record this again at some point. That's too bad.
Sorry.
But thank you for the yeah. But yeah, so Silva, it's really a hosting setup that's made to work within an organization where you already have an existing trust. And from the various organizations that we work with, this is an idea that got a good amount of interest from the larger organization that like universities or these kind of like larger public or public-like organizations that have sometimes internal teams with hundreds of developers, but they're all in-house people that pretty much they trust. And so we're kind of decoupling the infrastructure from really the direct billing of the resources that are being used. And the benefits that we have from that setup, well, there's a long list, but pretty much it's a self-service system. So the only thing that you need to create a new environment, you just need to create a new repository in your organization. You enable Circle CI, and boom, you have your environment. So there's no need to have some kind of like ops team intervention to enable people. People can do that themselves. And so that means our ops team can actually focus on our things. It means, for example, when we had the Gatsby workshop yesterday, we needed an environment for that. Mario created that environment. Like outside of business hours, nobody realized that he created that environment. And then we came the next day and like, oh, well, apparently he did everything and it just worked. And it's a fully automated process. We get on-demand environments. Pretty much for each branch, we create a dedicated environment. And what's nice with this is that we're testing not only the application, but also the infrastructure. So if we want to make some changes, we are really testing everything, every single commit. Also, one thing that's quite unique that I haven't seen in other places is consolidated access control. So we know that we manage access control on GitHub. So we give access to specific repositories, to specific developers, and we can then use this information to provide access, like SSH access to specific environments. So and also Circle CI provides access based on your GitHub credentials. So that means that when a developer has access to a project, they have access. There's no need to, hey, could you add my SSH key there? Or could I have access to the logs or these kind of things? All of that, it's consolidated. And that means that we don't have this small interruptions in the workday where it's like, okay, well, I'm just asking for access and then I just need to wait a minute until somebody's creating that for me. So everything is really there right away. We also have a flexible architecture. So we're using Helm. We have a Helm chart that works for Drupal, but we also have a Helm chart that works for static sites, and there's really nothing that prevents us from being really flexible and from deploying other kinds of software on that same setup. It's also cloud agnostic, so we don't have anything that's really specific to Google Cloud. We are also using, we know that there are others that are using our Helm chart outside of Wunder, and they're deploying on Azure, and it's also working quite well for them. So this was actually a very nice confirmation that our setup actually is cloud agnostic. And I think the last point, this is really important. Teams own their architecture. So the teams should be able to decide, just the same way that they decide what modules they want to use, they should be able to decide what components, what services they want to use in a decoupled setup. So starting a new project is actually quite simple. You just create a new project, you enable Circle CI for that project, and the default, you just run compose install, yarn install, so you have your log files, you export configuration, push the changes, and there you have your environment. That means that pretty much like 5 minutes, well, it depends how quick your connection is for Composer install, but a few minutes after creating the project, you pretty much have your first running environment. And the Circle CI configuration can actually be quite complicated for all those things. If we want to validate the code, if we want to build Docker images, we need different credentials. And this is the part where we were able to simplify things quite a bit using Circle CI orbs. So if you don't know what an orb is, it's Circle CI's name for a package. I'm not sure why they didn't call it a package, but I think there's already too many kinds of plugins and packages. But we're pretty much defining our own orb, and then the default configuration that's in the project actually just makes a reference to it. And so here we just say we want to validate things in the standard way. We have the possibility to override this and to have some of our own validation, project-specific things, but we have some default validation. And that means that when we are improving things across all the project, we have the possibility to make the changes in one place and then only have those changes, and have those changes be reflected on every project. And because we have semantic versioning there, we can also have some proper, making sure that we have the possibility to make backwards compatibility breaking changes if needed, but we just need to have the right versioning for that. And then for the deployment, we also make it possible to modify the building part. So how you run, Composer install, by default we use Yarn, but we also still have some projects that are using NPM, and we want it to be flexible in that. So it's possible for different projects to have different configuration. But then when it comes to the Docker build process, actually this is something that's pretty much the same across each of the projects. So we don't need to make this configurable by default. So we have a pretty good balance between having something that's common, a shared standard where everybody benefits from the common improvements, and at the same time having the possibility to have some small overrides that are really project specific. And then we also have some possibilities to configure the environment. And we have a silta.yaml in our repository, and this is really just the values file for the Helm chart. And by default, it's empty because the default values are actually quite good. If you want to make some modification, we have some documentation on all the possibilities that you have. But usually, we want to make those to keep that configuration as simple as possible. So, for example, if you just want private files, you uncomment these two lines. You say, "Yes, I want private files." Under the hood, quite a few things will happen. We'll have a persistent volume claim that gets created. That volume gets attached to the the Drupal pods. The environment variables get set within Drupal, and then Drupal becomes aware of those private files. But it's still one line that we need to add, hey, yes, I want private files, or I don't want private files. So we have a lot of those options. I'm not going to go through each of them, but we really have a lot of things that are flexible in those environments. If somebody would need, for some reason, a lot more PHP resources, that's totally fine. More CPU, more memory. You want to change basic authentications, inject different kinds of variables, configure PHP, have different kinds of cron jobs, and so on. So you really have the possibility to have a lot of control over different things, up to things like reference data. So for example, when we create a new environment, we base that environment on snapshots that was taken from the reference environment. This is something that works. For what we do by default, we just do a database dump that has sanitized data for GDPR purposes, so we don't have any sensitive data. That's also something that developers can easily have on their laptops without any risk. But in some cases, if you have a database dump that has like a few hundred gigabytes, you probably don't want to move that around for every deployment. So we have the possibility there to determine how do you generate reference data for your project. So for example, we only keep the last 1,000 nodes and things like that. And so a good example for when we want to use these configuration options is for the production environment. So there, for development environments, we generally want to say, hey, you get the minimal amount of resources guaranteed to make sure that things are running. It's not going to, we're not going to, like in PR environments, you're not going to have more than 1 or 2 users. So we don't want to allocate a lot of resources. It makes it a lot more efficient for us to have a lot of different, to have more things running on the same cluster. But then for the production environment, we actually want to have multiple replicas. We want to have more dedicated resources. Probably for the production environment, you don't want basic auth. would kind of make sense. So these kind of things that we can really provide specifically for the production environment. But we could also use exactly the same configuration for production-like environment. So if we have issues that are occurring only in production, we have the possibility to set up a separate environment that's going to behave exactly like production. So this is not something that's like hard-coded, that it has to be only this environment. So yeah, this is like a big simplification, but how things work for our development environment. So we have Ambassador. It's a microservice API gateway that actually fits our need really, really well for this. It pretty much provides the ingress. And it means that each of our branches get to define, hey, this is my URL, this is the domain that I'm going to be available under. And so it means we don't need to actually keep track of which environments are in a central place. Pretty much every single environment has an annotation in its Kubernetes service where it says, hey, I have this URL. And this actually works very nicely. Ambassador has a lot of really cool stuff like shadow traffic and canary releases and things like that. This is really exciting technology, but for the development environment, it pretty much simply makes it available, like possible to have pretty much each environment determine its own URL. So typically it's going to be branch name dot project name dot cluster domain. And there we have dedicated pods also for database and for Elasticsearch, all of that running as pods within the cluster. For production, then it looks a bit different. There we have a CDN. We also want to have a dedicated ingress. That's something that we might need to revise, but that's something that actually works quite well already. And yeah, then actually we have our Nginx and PHP, so containers running within the Drupal pod. This is something we run in high availability, but then the database, we don't host that necessarily inside of the cluster. There's one general piece of advice that pretty much hear over and over again when talking about Kubernetes or container-based infrastructure. Don't persist your data within the cluster. Cluster is meant the pods are going to go away at some point. So for anything that really needs to be persisted, we delegate this outside the cluster. So the database is outside the cluster. Elasticsearch with a standard search solution, we put that outside of Elasticsearch if we persist data that's not elsewhere. So for example, if it's just a search index for data that's in the database, it would be totally fine to have that in the cluster if we are able to reindex quickly enough. We also have an increasing number of projects where we actually use Elasticsearch as primary storage, and then in that case, of course, you want to have that being persisted, and then of course outside of the cluster. And then, well, as I was talking about Gatsby, for example, it also means that we have certain things that, why host these on a Kubernetes cluster, which is a pretty complex setup, when you can just put them on static storage. Just get a static storage bucket, point your CDN to it, and you're good to go. So this really saves a lot of money and also gives you a lot more stability. And then something that we've also been starting to use recently is also different kind of serverless tools. So using the serverless framework, but there's a lot of possibility there to host Node.js or JavaScript code. It works best in places where the latency is not the biggest concern, but this is something that can also simplify our architecture quite dramatically. And then, well, actually, if you look at this picture, you see that most of the things are actually running outside of your Kubernetes cluster. And there's a lot of things there that, yeah, maybe you might think, it's actually pretty complicated, pretty complex. How do you manage all these things? And so you don't want to be setting up all of these things and managing them and upgrading them manually. And this is where Terraform comes in. In Terraform, it's pretty much a service orchestration tool. So you pretty much define what end result you want to have, the same thing as with Kubernetes resources. And Terraform will then make sure that it provisions your cluster, your different services and so on. And so this is something that we are already using to create and to manage the cluster itself. So all the changes that we do to the cluster are based on code changes. So we really truly have a true GitOps process. But we are also, this is not something that we have done yet, but we have the possibility to use Terraform to manage those external resources that are outside of the cluster, but are still tied to the project with Terraform. And just a quick example, this is something like how it looks like. So we defined our node pool, and so actually really simple configuration. We just have some variables, and so we have the Terraform module definition that determines what kind of structure we have, and then we have a dedicated repository where we have the configuration for what zone we have and what machine type and so on. And this leads me to the third part. So the development process, and this might be the most important one. And I saw this slide, and actually I saw this slide on a video of somebody who was talking about not a presentation. If you know where this slide comes from, please let me know, because I've seen this without attribution, and I really like it. But yeah, if this is not mine, and if you know where it comes from, that would be great. But I think this is absolutely true. Like the splitting of code into microservices, which is pretty much the same principle behind decoupled architectures. It means, well, it's an extension of Agile to the next level. And it means that we are getting results much faster. It also means, for example, a very concrete example, if we are building the front end decoupled from the back end, it means that we can start with the front end, creates the visual aspect, the part that the client actually really cares about. I mean, nobody cares about the back end. And we can do that. We can start the work on the first day of the project. And then once the client is happy with the front end, we will build the back end. And so we focus on those things that really provide value to the client. Maybe those things where you will need more time to iterate. And by doing that, we really have the possibility to minimize the risk as quickly as possible. If we want to iterate that quickly, we also need to make sure that quality is coming along. And there, it's good to have helpers, because we want to move fast, but we want to have tools to do the work for us. We have a lot of different tools. Well, PR reviews, that's kind of a given, but also using, for example, GitHub status. So making sure that the status of the different checks that we have is reflected on GitHub. That means I'm not going to bother a colleague asking for a review unless the automated checks have already gone through. And then we use Circle CI for that, but we also, and we use standard things like ESLint and PHP-CS. It might seem like very simple tools that, it's very easy, but actually providing simple tools like that, this is the kind of gateway to getting your teams to really understand why is it important to have pull requests and why is it important to have this kind of review process. Then you can have all your test frameworks. So using Codeception, this is something that we use also quite heavily. Also using React component tests, so pretty much unit tests for your front-end component. And we also have one tool that we started using that's been really great. It's called Dependabot. And Dependabot is a tool that looks at your dependencies, so Composer packages, NPM packages, Docker images, Terraform modules, and so on. And it creates pull requests automatically on a regular basis if there are an update. So you can configure it every week, just check for updates and create pull requests. And then when there are security-related updates that come from known sources, like for NPM packages, for Composer packages, it will create a pull request right away. And that means that it's a lot easier to move quickly, but also to keep your code up to date. And then the per branch environments really give you a lot more stability in terms of like making sure that you have the right quality. And this combination of Dependabot with the per branch environment means whenever there's an update available, Dependabot will create a new branch. That branch will be deployed, and you pretty much have the possibility to check, hey, this update, does it work right away, without even needing to check out the code to deploy anything yourself. And this also brings us a lot of certainty. And this is something that if you want to deploy more often, if you want to deploy multiple times a day, you need to have certainty that things will be okay. There's a lot of organizations that have kind of outdated processes and the kind of waterfall-like setup where before you release anything, you really need to have a bunch of dedicated time just to make sure that everything is okay. And if you need to have these kind of big release windows, then it's going to make it very difficult to it's going to make it very difficult to release things on a quick base. And so what can you do to increase certainty? Well, of course, logging, monitoring, things like that. But then when you have a decoupled setup, you want to do things like request tracing, so that you know, how do I debug this request that came in through here, then went to this servers, and then split off into one request here, one request there. So this is something that's really useful, that you really want to have. Also, shadow traffic. This is something that I actually did not know that this was possible before. But using Ambassador, for example, we have the possibility to send all the traffic to the production environment, but then make a copy of that traffic and sending to the staging server or another server of our choice, and just ignore the response. And what's the purpose of that is that, well, we get to test what would happen if we had launched this new version of the code. If things break, that's fine. Nobody will have seen that, but you really get to see what's the performance of the new changes that we have. Really, like what would have happened if we had launched. And so it means that when you actually launch, you get to see, hey, well, you get to launch pretty much like without any kind of surprises. Also doing things like canary releases, where you send part of the traffic to a dedicated site. If you have your front end in Drupal, this is not possible. You cannot have different versions of your code talking to the same database. The reason is that Drupal pretty much stores your code in the database. There's such a tight coupling between what modules are enabled and what modules are enabled in the database and what code you have that's present in your code base. So if you have a traditional Drupal front end, it's not possible to do a canary release. And yeah, automated tests also definitely something that you want to have. This gives you flexibility. It gives you flexibility to change things because you have the safety net that make it possible for change. And this flexibility, giving this flexibility, this freedom to your team, that's pretty much what gives them ownership. And this is really something that's important. So by moving this, which like a tool that actually originally made us very happy, or it made me very happy at least, if we realize that it's not the right tool, then we can also move that to dedicated tools that really make us more productive, gives us something that's, something in the end that makes us happy. And this is something that I think everybody should care about. So, any questions? Yes?
Would you build it again with Helm?
There are a few things that are annoying with Helm. At the same time, I haven't seen a better alternative. So at the moment, there's a few things that are annoying, but otherwise, I think it's we would still be.
We're at the point where we think about it.
Yeah.
So maybe we should talk a bit more. But we're thinking about building a Drupal operator and use the operator system rather than the Helm system.
Okay. Yeah.
Because we had a lot of issues with Helm of like just stuff be gone, or you have to like delete it to update it.
That's definitely, well, there are certain things that are a bit annoying. We've managed to have a few things like that check for these kind of conditions, but it's definitely a tool that could be improved. We've been following the Helm 3 plans, but yeah, no idea when this will be released. Yeah. But yeah, we should indeed talk about that. Yeah.
I guess I go next.
Yeah.
Do you create a Kubernetes cluster for every single project? Or like, how do you decide how many clusters do you have and how many projects do you deploy in one?
So we pretty much have one cluster for all the development environments, where we pretty much put everything, or like it's the default cluster. So unless we have a reason to put things elsewhere, we'll put it there. And then for production, we are kind of like, well, one production environment, and then that kind of depend on some clients. Some clients want to have a dedicated cluster. Some clients have a dedicated account that's going to be outside of Google Cloud, so that's going to be a dedicated cluster anyway. So I think for production, it pretty much depends on the needs, and then otherwise we have everything in one central place.
Okay.
Yeah.
What do you use for logging?
For logs? So actually, well, this is one thing that we've postponed quite a bit, because actually Google Cloud provides much better logging than, for example, AWS when it comes to Kubernetes. So you actually have some good logging by default. We're looking at so we have FileBeat in place to get all the logs, and then also evaluating New Relic. So it's New Relic for monitoring, and then FileBeat for the logging. We need to do some more comparisons, but yeah, we already have the logs that we can read through. It's just a matter of having something that's nicer to take a look, and also better support for alerts. Okay. So if you have any questions, you know where to find me. And otherwise, I guess I'll see you at the Splash Awards. I forgot to have the dedicated slide, but don't miss the Splash Awards. And also see you at the Wunder tonight.